On our second trig ratios lesson, we are going to learn about finding angle measurements instead of sides. So to do that, we're going to use what's called an inverse trig ratio, and then we're also going to come up with this thing called a unit circle. We're going to build some angle measurements in it, and then the coordinates, xy coordinates around the outside of it. That's going to give us a way to find the exact values of different angle measurements, the sines, the cosines, and the tangents. Okay, so here's a setup for example 1. If you knew that you got two sides of your right triangle, you had a 3 and a 4, let's just say, we want to know what this angle measurement that it's opposite that small side, or even this other one, the one that's across from 4. What we want to know is how can we get that angle measurement? Well, we know that we could just set up, this is the opposite side and that's the adjacent side, which is the tangent ratio. We could just set up that, but we want this angle measurement. We want the angle measurement, not the ratio, because we're already given that. So what we want to do is we want to work backwards. And in mathematics, when we work backwards, we're using an inverse. For example, the inverse of adding is subtracting. The inverse of squaring is just taking the square root. So let's look at this from an algebraic point of view. So here's a table of values. This is the original relationships. You can see that x is 0 and 6, 1 and 4, 2 and 2, 3 and 0, etc. The inverse, it switches those things around. So instead of 0, 6, I have 6, 0. Instead of 1, 4, I have 4, 1. Okay? If I look at the graph of this thing, here's the original function, the one that's bold in black. An inverse reflects it across the line y equals x. So what an inverse does is it gives you a way to switch the inputs and the outputs. Instead of given the input and you try to find the output, you're given the output and you want to find the input. Okay, so explain what x and y represent in sine y equals sine x, and then explain what's meant by the inverse. So the x is the input. Okay, it's what you put in. And what do you put in for the sine? You put in an angle measurement. Like it could be 30 degrees, 60 degrees, whatever. Okay. The y is your output. It's what we're supposed to get as an answer. What do we get out of the sine ratio after I put in my angle? I'm going to get the ratio of the sides, right? It could be something like 3 to 5, whatever. Okay, so what an inverse is going to do is it's going to switch these. So now your input becomes the ratio and the output becomes the angle measurement, which is what we want. So let's look at a couple of graphs. Here's a linear equation, f of x equals 2x minus 5, or y equals 2x minus 5. We want to know what is the x value when the output is 3. In other words, the y is 3. What does the x value have to be that goes with it? So we can just look at the graph, follow it straight across, then go down, and obviously that is the number 4. It's 4, and that's the only value that's possible. Okay, if I stick in the number 4, I'm only going to get 3 coming out. Or if I work backwards, my output is 3, the only possible number that's going to come out of it, that must have gone in, was a 4. So let's look at the parabola though. In this parabola, we have g of x equals x squared minus 5, or if you would rather have that as a y, whatever. Let's do the same thing. We're going to work backwards. We're given 4 as the output. So this y value is a 4 equals x squared minus 5. If I look at the graph, follow it straight across like I did before, and I get the number 3. The problem is that when I do it on the other side, I also get negative 3. Okay? So the problem with this one is that you have two outputs. You have a negative 3 and a positive 3.